interactive demo type thing of how to write a short program in wxPython. Before I get into the demo, I'm going to tell you why you would want to write a program in wxPython. wxPython is a GUI toolkit that is cross-platform and uses native widgets on each platform. This means that on Windows, the program will look like it's a native Windows application. On OS X, it will look like a native OS X application, etc. The main targets, or the main backends for wxPython are MSW, Windows, OS X, and GTK. So you can get native interfaces on those three platforms. This means that things like the menu bars will show up at the top of the screen on OS X instead of underneath the title bar. So a lot of that stuff is handled for you. That gives applications a somewhat professional feel. It also means that there are some things that you have to have in mind about different platforms, because not every platform will do things the same way. So it has upsides and downsides. Another benefit of wxPython is that it's relatively easy to code. For example, if you want to write a Windows GUI application, it's much easier to write it in wxPython than in the basic Win32.API. Like a factor of 10 or so difference in the number of lines of code you have to write. No exaggeration. You can get wxPython from this website. There are a few different versions. There's the stable versions and the development versions. The stable versions, it follows the same release numbering as the Linux kernel, so even numbered minor versions are going to be stable versions, and odd numbered ones are going to be unstable. So 2.8 is the current stable branch, so go ahead and download that and install it if you can. For learning how to use wxPython, there's the wxPython wiki, which has links to a number of tutorials. The getting started one is pretty good. So the wiki is wiki.wxPython.org, and that will take you through most of the basic things in how to write a wxPython application, and some of the more advanced things. So that's a fairly complete tutorial. There are also several others. There's also a wonderful tool, the wxPython demo application, which shows you some code for various controls, widgets, or whatever, as well as allows you to demo, not that one, allows you to demo what these things do. So this is a frame with a panel and a close button. And so the wxPython demo application is a great way to check out various controls, to look at some usage examples so that you can see what the basic options are and what they do and so forth. So also, if any of you have any ideas for a very simple GUI application that you'd like to see written, something with maybe a few input boxes and maybe some sort of calculation or output, think about that, and if you can come up with something, let me know at the end and we'll try to make it. Right now I'm going to go through the basics of how to write a very simple skeleton WX application. First thing you want to do is import WX.
Can you increase the font size?
Sorry?
Increase the font size.
Oh, yes. That good? After that, you need to make an app object. There are a few different app objects available. The WX app object is the most commonly used nowadays. You might also see in some earlier tutorials PySymple app. And in older versions of wxPython, there was actually a difference between app and PySymple app. Nowadays, there's really not. App takes two optional arguments. The first optional argument is whether to redirect standard input to the console or to a separate window or to a file. So redirect can either not exist, and that means it will redirect to a window. It can also either be 0, which means dump to the console, don't redirect anything, or 1, which I think means redirect to a file, but maybe 2 is a file. Okay. And then the second thing is, if you want to redirect to a file, I think it's target equals, or something like that. I'm not sure of the exact usage there. I usually use 0 for debugging so that I can see the output of anything in the console. After you've created the object, you can then start creating windows and controls. So the 2 top-level windows, or 2 top-level objects in wxPython are dialogues and frames. And there are several different types of dialogues, and there are 2 major types of frames. A frame is basically the stuff on the outside of the window. So the title bar, the menu bar, the status bar if you have it, and the borders. So a bare frame, parent equals 1, will be what we'll make first. After you've created all the objects, you'll need to enter the main loop. And that is, oh, and one other thing. You need to show frames. Show false will hide a frame. Show true will unhide the frame. And I called this eggs.py. So let's run eggs. So here's a frame. It's pretty boring, it has nothing in it, doesn't have a name. You can see right now that the eggs program is running because it's not giving me a new command prompt. As soon as I close it, the program terminates. So looking into this a little bit more, we've got the parent argument. We also have a few other arguments, optional arguments, in the frame constructor. So parent is the first, that's mandatory. There's ID, there's title, position, size, style, and name. So the parent is mandatory for all objects and controls. And by the way, in wxPython and wxWidgets, a window is anything that has real estate on the screen. So this is a little bit contrary to the normal thought of what a window means. So if I say a window, I mean something that has real estate on the screen. The reason for this is that there's a class called wxWindow, wx.window, and that's a base class for pretty much everything in wxPython. And that base class gives you stuff like get position, get size, set size, and so forth. Yes, frame has the first argument of parent. All windows have a parent, except for dialogues and frames, which optionally have either a parent, which is a window, or none. And if we create 2 things that have parent none, like say we create a dialogue, and let's make it a message dialogue. And of course, you have to be true, I'm not sure. So if we have 2 things, if you have 2 things going on, then you have to close both before the application loads it. And I can't remember why I'm not getting the dialog showing when I hit show. The difference between showing the modal and showing for dialogues is whether it locks up all of your input. So right now it's showing modal, and I can't access my frame. let's get rid of this dialog. Frames by themselves are not very useful. They're ugly for one thing, and they don't have very complete functionality. If you want to put anything inside a frame, it's better to put a panel inside first, and then put everything else on the panel. A panel is just a section of real estate that serves as a surface for other objects. It's kind of like a table surface that you can put remotes onto or whatever. And the panels are created like so. Now, panels are not top-level objects, so they require a parent. And we're going to make its parent the frame. And once we run this now, we'll see that there's a little section. Well, there was originally a little section that was a different color. That's the panel. As soon as we resize it, the panel fits to the full size of the frame. And that's because of the layout function of the frames and panels. So now we're going to get into more complicated stuff, layouts. If you want to put more than one control on an object, there are two different ways of doing it. You can either use absolute positioning, and with that you would create a control like parent equals something, and you'd specify explicitly what the position is. And you'd specify size for some objects as well. This, of course, is not very flexible, but it's really easy and quick to do. So it's not recommended to do this for most situations. The other main way of doing layouts is using sizers. And sizers are kind of like containers, but they're not windows. They don't have any real estate usage of their own. But they will collect together a bunch of other controls and windows and objects and arrange them so that each one has its minimum specified amount of space, and optionally so that they grow in a fashion to take up all the available real estate. The basic sizer is the wx.box sizer. And when you're creating a box sizer, you have two options. You can either make it so that it's oriented vertically or horizontally. So a box sizer is a one-dimensional layout system. It allows you to lay out objects in one row or in one column. You can nest sizers. So if you nest, say, one vertical sizer and then 5 horizontal sizers within that, you could have a 5 by arbitrary table-like thing. When you do this nesting with box sizers, each row will have, if in this situation we have one vertical and sub-sizers that are horizontal, each horizontal sizer will have different alignment and optionally a different number of children. So using box sizers in this way is more flexible, but potentially uglier than other situations or other ways of doing it. There's also another sizer that's very similar to box sizer. And it's kind of lame. It's the same thing as box sizer, except that you have to, or it gets a box drawn around it. You have to create this separate, you have to create separately that box, that static box. And so it's not that useful and it's hard to use. The other sizers are all grid sizers. So they're inherently two-dimensional sizers. The basic one is, I think, grid sizer. Let me check to make sure that I have that right. Grid sizer, yes. run help on any object in wxPython and get the doc stream, it's good to have an interactive window, interactive Python window, especially an interactive IPython window running, so you can just look at the doc streams. It's a lot faster than looking it up online. So down here is the, can you guys read this? Anyway, down here is the description of a grid sizer. A grid sizer is just a two-dimensional grid in which all the cells are the same size, and you can add objects, you can add controls or windows to any one of those cells. It's the least powerful and least flexible of all the grid sizers. All the other grid sizers are supersets of the functionality of the basic grid sizer. So the next step up is flex grid sizer. And flex grid sizer is a grid sizer, but it allows you to specify certain columns or certain rows as being rowable. So you could say equals wx flex grid sizer, and then later it's just equitable call. Specify column 2 as being rowable. And this will mean that whenever you resize the window, when you resize the frame or that section of the frame, then the sizer will cause column 2 to change its size in order to make sure that everything fits. There's also add rowable row. Changing the size of the column or the row by itself won't necessarily change the size of all the elements in that row or column. We'll get into that in a little bit, but just keep that in mind. There's one other step before everything will row to fit the space. There's also the grid bag sizer, which is a flex grid sizer with one additional major feature. You can have instead of just having single cells and one control or one window per cell, you can have a control span multiple cells. So when you're adding something, you would specify, so let's say we created our grid bag sizer, and then we're adding some control to it, say a static text. It's add. Pause equals so when you're adding something to a grid bag sizer, you have the option of specifying exactly where it goes in the grid, and also how much space it takes. So this object would take 4 rows from row 2 to row 5 inclusive, and 4 columns. So the grid bag sizer is the most powerful of the grid sizers. You can also just specify a span of 1, and if you don't specify columns as being rowable, then it just becomes equivalent to the grid sizer. So we have the box sizer and the 3 grid sizers, and those are the way that you lay things out. When you add stuff to them, you create the text or the control. You specify its parent as being the panel, usually, that it's being laid on. And then after you've created it, you add it to the sizer. Better practice is to do something like this. So that's the process for adding things to sizers. For the box sizer, you don't have the ability to, or the default way of adding things isn't to add it to a certain position, but just to append it to the list. So you have and then like that. So you do this for any number of items you have. And you also have one other optional argument to the append function and to all the other adding functions for the flux grid incisors and the grid data sizer and the grid sizer. And that's the flags. The most important flag is expand. It's flags. And objects that are appended with expand will expand when you change the window size so they take up all available space. If you don't have this flag set, then that object will, the static text or the button will always be its minimum safe size. So you can choose which things expand and which things don't this way. And there are no, when you're adding it, you don't specify horizontal expansion or vertical expansion, just specify expansion, and that will allow it to expand in either direction if the site supports it. There are also a few other flags that you can use. You can also add borders, either to the bottom, the top, the left, the right, or all. You can also specify the border size. So those are all the options for the append function. So going back to our application, let's add a sizer to our panel. Let's just start with a box sizer. And here's the arguments. So box sizer does not have a parent argument. You don't have to worry about that yet. And then let's create a button. And let's make the panel the parent of the button. And let's give it a label. Then we append the button to the sizer. And what is that? Okay. Going to add the item as a button and flag. Let's make that start expand. And let's do next dot order equals 10. And then there's one other step before the sizer will become activated. And that's that you have to set the sizer as the sizer for the panel. So you'll notice that when I'm entering things in, I like to type in the name of the class first so that I get the pop-up menu. That's why I'm doing that anyway. So you set the sizer, and optionally you can tell the sizer to do its layout function. This reduces glitches and bugs in the layout. So once you try that, oops, there we go. You have this This is a horizontal sizer. So the sizer is going to the right, and it's allocated one spot for the button, and it's allowing the button to expand in the vertical direction. And that doesn't do anything yet. And we'll look at some more complicated versions of sizer layouts in the rapid application development section. So let's just leave that at this for now and move on to actually doing stuff. So far we've got an application that doesn't do anything, and that's kind of lame. We want applications that do things. And the way we do this is with callbacks and with binding and with events. So in wxPython, in wxWidgets, lots of different things will trigger events. And most of the time, those events will not have a handler, and they'll just be ignored. So for example, whenever you move the mouse over an object, that triggers a mouse event. Whenever you click the left mouse button on anything, even if it's not a button, that triggers a mouse event. A mouse left down and a left up event. If you want to catch these and do something with them, then you have to bind that event to an object and to a handler. Or, sorry, you have to bind that event at an object to a handler. So let's do this as a function. And when we get to a button press, let's create a message dialog and say hi. So and dialogues again don't have to have a parent. When they don't have a parent, they'll prevent the application from exiting until they're closed. And we can label caption message. Just having that function doesn't do anything, we have to bind it. So there are a couple of different ways of doing this binding. The most common way is to use the object that's creating that event, in this case the button, and tell it to bind all event types have the EVT prefix. So if you're ever curious quickly what kind of events you have and you don't want to look online, you can just look at all the EVT whatever event types. So if you're looking for the mouse event and you want to know what it is, there's that. Mouse capture logs, capture change, mouse wheel. Motion is actually keyboard motion. But, yeah. So we're looking for EVT button, and we want to bind it to handle button press. And when we do that, we notice that we defined things in the wrong order. So now we have a little button that does something. Not anything useful right now, but it does something. So let's go to timers now. Let's add a little bit of text to our meaningless application. let's not give it a border. Let's change this, let's get rid of this dialog. And whenever we click that button, let's increment the text on this static text. So, now it's 2, now it's 3, now it's 4, now it's 5. It's up here. It's kind of hard to see because of the resolution. Anyway, so now we've got a little counter. You don't always want to do things tied to user input and to user-generated events. Sometimes you want to be able to take control of things yourself. And it's not a good idea to have wait loops in GUI applications because wait loops or long-running processes or functions will lock user input out of the application and make the application non-responsive for as long as you're doing that operation. So for example, people won't be able to resize the window or minimize it or maximize it for as long as you're in a wait loop or a calculation loop. So a better way of doing things is just to have if you want to pull something every second, you can create a timer. And you can specify an event handler here or later. Let's specify it here. And then, let's see. Oops. It's the start. We want to do it every 1 second. You have the option with timers of having them only trigger once or triggering multiple times. So let's make this go every second. And let's do same thing that's in the button press. So okay, this is not how you specify event handlers. You have to bind them. So I mentioned there are 2 ways of doing bindings. You can either bind at the object that's generating the event, or you can bind at one of the objects above, one of the parent objects for that. And the parent objects won't catch all of the events. Not all events are propagated up to parent objects. Usually, user input events will be, but GUI events like resizing or closing a window will not be. I think timer is, but I'm not completely certain about that. No, actually, wait. Yeah. No, I'm going to have to look this up. Sorry. That's very good. get it cut in frame one more time. So again, looking at the parameters, the first argument is the event type, second argument is the handler, and the third argument is the source. If there is no source, then it will only collect self-generated events, I think. Maybe it'll collect any event. Anyway, the source argument is usually optional, but it's a good thing to specify it, so that you only collect events from the source that you want to collect it from. Okay, so work now. And it's not working. Ah, that's right. Let's do that. There we go. So when you're creating the timer, you have to specify where the event is going to be generated, where the timer event is going to be generated. And because I'm binding the timer event at the button, that's where I created it. I could also probably have this be panel, and it would still work. So, well, great. Okay, yeah. So that's a quick overview of some things in wxPython. I'm not an expert in Python, or wxPython, obviously. Just hoping to show you a little bit so you can get an idea for how applications in wx are written from scratch by hand. So that you're not daunted by it, and so that you can have more confidence in getting your feet wet in. Now I'm going to show you one of the rapid application development programs called wxBlade. And wxBlade will allow you to quickly and graphically create simple GUIs, simple static GUIs. It's limited because you can't create GUIs that respond by creating controls in response to user input. You'd have to do that by hand. There are also a lot of other things that you can't do. But for creating simple things or for creating skeletons of applications, it can be very useful. I recommend that you don't use wxBlade for your first applications, because if you do that, you'll get spoiled, and then you'll never learn how to actually use wxPython, and once you need to do something more advanced than that, you'll just not be able to, and you'll get frustrated. So avoid using this for later, but keep in mind that this application is available for doing things once you are deserving of it. So you can create a frame by hitting the frame button. You can create several frames, and that'll show you the frame here. You can see that it creates the frames with slicers by default. If you want to create a panel, you go to the Add Panel Screen window thing, click on it, and then click where you want the panel to show up. You'll see that if you try to do that again, it doesn't do anything. If you want to have more than one object in a sizer, you have to tell the sizer to add a slot. So now that we added, now that we added 2 slots, you can see there are 2 empty spaces here. So we could add a spin button to one of them and a toggle button to the other. And you can see the panel grows to fit, but the other two objects do not. You can edit some of the properties of these buttons in this little window. So we've got some layout information here. If you want a border, you can add borders. Let's do there we go. Often changes you make to borders or layout things won't update until you resize the window. That's because when you resize the window, that triggers the resize, AVT resize event, which triggers a handler in the default frame code, which in turn triggers the layout function of the sizer attached to that frame. So as soon as we resize the window, you get the button border changing. If you want to programmatically induce that layout process, you just call the sizer's layout function. Of course, you can't do that from within within Glade, wxGlade very easily. Oops. With this spin control, we can also specify ranges. Let's see. There should be some other options here. There should be an option for a label. So wx doesn't give you the option to set the value, or the name rather, option. The name option for, where is it? This guy. The name option I think shows up to the left of the spin control. Whatever. So you can also add separators. You can also do nested sizers. So if we add a box sizer here, we make it horizontal, and we can add some text here. And a couple slots. We add a radio box with options. I can have this radio box. Radio boxes will allow you to select only one of these options in case you aren't familiar with them. You can also add a choice here. And pull down choice menu. So yeah, that's wxGlade. You guys are awfully quiet. Questions? Suggestions? Anything you want to see? Are you bored and want me to stop talking so the next person can go?
How do we, in wxGlade, how do we connect back to a database to fetch choices? So do you write code for that? Or
oh, right, yeah, of course. That's a good question. So once you've got this GUI thing in WX, what then? Oops, forgot. So you should probably save it somewhere. So let's go to the option. Go to the application and specify an output path for it. And then you generate code. Yeah, generate code. And then you have some code here. So then you can go in and specify handlers or things like that. There's also a way to specify a little bit of handler information within wxPython itself by clicking on the object and go to event and specify something there. So notice that I'm doing it for event spin, but not up or down. We then go back and generate the code and reload it, spin event. And so we've got this stub right here. So I mentioned how many events, especially events on controls, things that take user input, will propagate up the parent-child hierarchy until it gets caught. There's a little counterintuitive function called skip, or method called skip. If you call skip on an event, then that event will keep going even though it was executed at this handler. So they just have skip here on this handler to make sure that if there are other handlers that you have written code for, those get called to handle this event, even though it's getting handled here. Using skip, you can handle single events more than once. So if you have multiple things that need to happen when a single event is triggered, you can do that using skip. There's also the ability to add additional code, but I'm not sure how this works, mostly because I don't actually use wxPython myself. But yeah, you can probably, I don't know, maybe even define spin event here with the extra code section. All right, other questions?
How is that custom components? Like suppose you have not added a figure.
Sorry, can you talk louder?
How do you specify custom component? Like from the widget I can see like very limited set of components. I can say the arrow, I can say the Xbox, all these very limited components. So if you have to write a custom component.
Custom what?
Custom component.
Component?
Custom component, like a date picker or something like that.
Right. So you can inherit, you can use inheritance to create subclasses that say are based on static text or whatever, or on the spin control, and that have extra code with them. You can also, if you want to have a distinct appearance, you can do that using drawing contexts. So if you want to draw your own components, like a clock, an analog clock, you can do that. The way that you do that is you catch repaint events. So EBT_paint events will get created whenever part of the control gets covered or uncovered and needs to be redrawn. And whenever that happens, you create a drawing context, and there are a few of them. Let's see. The basic one is DC. There's also graphics context, memory context, mirror DC, etc. Auto buffered DC. OS 10 will double buffer by default, Windows doesn't. So auto buffered DC will double buffer on Windows and Linux, but not on OS 10. Whatever, anyway, so you create a DC drawing context, you draw to it, and then you, I think, blit it to do something when you finish drawing to put it back onto the actual display. I forget what it is though. Yeah, more information in the documentation, sorry. But that's the general idea. Does that answer your question?
Yeah.
Any other questions?
How about the key event distance? Key event issues. Key
Key,
event issues. Key press event issues.
sorry, what?
Key press event issues.
Key press event listeners.
Okay, key press event listing. Okay, so, yeah, sorry, I have a lot of problems with Indian accents. I've only been here for like 4 months. So it does help if people with sort of westernized accents interpose. So you can catch cursor movement. It's, yeah. You can catch cursor movement with EVT motion. So the EVT motion is for cursor movement. If you have a text box or something else that some of the control that allows you to enter text in, they will trigger, in addition to the motions, they will trigger EVT text type events. So if you just press a key, that will trigger an EVT text event. If you copy or paste or whatever, that will trigger these other events. I think enter is just if you press the enter key. So you can have event handlers that only trigger if you have a new line entered. Of course, this doesn't tell you what key they pressed. If you look at the event that is passed to the handler, that will have information about what exactly happened. So with mouse events, for example, it'll tell you which mouse button was pressed and what the position was. And if you're ever curious what information is available in that event thing, you can always just write some simple application that triggers one of those events, catch it, and then print DIR on that event to see what's available. So yeah, you can also look online to see what's in the EVT text event. Oh, there's also EVT char. Okay, so EVT text is called whenever the text changes. EVT char is called whenever a key is pressed. Minor distinction there. So event.getString or event.getKeyCode will give you the specific information. Other questions?
So have you tried any other framework like Kiwi?
Hmm?
For example, in Python, there's a framework called Kiwi.
Kiwi?
Kiwi.
Kiwi. I don't know anything about Kiwi.
Okay, so the best part of Kiwi is like it works on touch devices.
On a,
Touch devices. You can build a GUI application on touch devices using that. So using that framework, you can try to create a GUI application which runs on a desktop, which runs on a touch devices. So just want to ask if you have used, what is the comparison?
yeah, I've only used WX's GUI toolkits. WX only runs on desktop style platforms. It does not run on mobile. GTK, I think, does run on some, or does GTK run on mobile?
But
Whatever, doesn't matter. Anyway, yeah, so WX is rather limited in the kinds of platforms that you can program for. It's a relatively old toolkit. The wxPython is actually a wrapper around wx widgets, which is written in C++. wx widgets is probably 15 years old, something like that. If you look in odd corners of the wx widgets documentation, you can see references to Motif. Motif used to be one of the backends in addition to GTK and MSW, so that can give you some idea for how old it is, if you even know what Motif is. Yeah. Anything else, or should I make room for lightning talks?